let's go over this. This shouldn't have taken long. So, Kamari, for A, is that increasing or decreasing? How do you know? Good, it's going down from left to right, so decreasing. And would it be more of a linear function or exponential? Linear. Why do you say linear? It looks like a straight line, right? You can see line is in linear. Perfect. Allison, what do you have for the second one? Increasing or decreasing? Beautiful. And does it look more like an exponential or linear? You're right the first time. Exponential, because exponential are curves. So see how it looks more like a curve than it does like a straight line. And then Jasmine, what's the last one? Increasing? Perfect. Because it's going up and it looks like a curve. Perfect. So, circle how you feel about that. That was pretty straightforward. Today we're learning about correlation coefficients. This lesson's pretty straightforward, but a lot of people struggled on this one too, just like yesterday's. So we're gonna go to that like half sheet of paper. Does everybody have that? Does everyone grab this? Does anyone not have it? Raise your hand. This half sheet of paper. Does anyone not have it? Anyone else not have this half sheet of paper? Anyone else not have this? Yes, no? Good. Okay. All right, so at the top, these are your notes for today. So at the top, you're going to write correlation coefficient. Just write it right here. And we use the letter R to indicate our correlation coefficient. I just remember in correlation, there's two R's, so R represents my correlation coefficient. And so we're going to learn how to get it in our calculators, but we're also going to learn like what it looks like. So there's two things we look at when we look at our correlation coefficient. What it means is how close together your data is to a line. So like if I were to draw a line that represents my data like this, see how all the dots are touching it? And same with this one. That would be very, very strong. That would be perfect almost. But see if I were to draw it through this, that some of the dots are touching it, but not all of them, that would be weaker. So the more spread out your data is, the weaker it is. So we identify correlation coefficient by a number. So it goes from -1 and 1, they're the strongest ones. And then 0 means there's no correlation. So when they're talking about R, we know our R is between -1 to 1. On tests, they may trick you, say like 1.3. There is no correlation at 1.3. That number is between -1 to +1.
Right there.
Yeah, so -1 to +1. Now, how we figure out if it's negative or positive is basically how you guys just saw increasing or decreasing. So if it's increasing, do you think it's like your slope? Is it slope positive or negative? So what about this one? Is this going to be positive or negative? Positive. So write positive underneath it. What about this one? Positive. This one? If it's going up, what's it going to be? Positive. So first thing we identify is if it's positive or negative. What's this one going to be? Negative, because it's going down. This one? Negative. And this one? Negative. See how this one's all over the place? There's no pattern. It's just a bunch of dots. Yeah, this is no correlation. So the first thing, that positive and negative is just if it's going up or down. If it's going up, it's positive. If it's going down, it's negative. Then we figure out if it's weak or strong. And so the stronger, the sign just means if it's negative or positive. The closer it is to 1, the stronger it is. So like right here, see how it's perfect, right? It's going to be a perfect positive correlation. So put perfect on top of it. That means it's going to be close to the number 1. This one, since it's perfect, it will be 1. So perfect just means like if I were to draw a line, all the dots would fall in place. This one right here would be a strong positive correlation. So like when I draw a line, they're pretty close to the line, but they're not perfect. So as long as the numbers, like this one could be like 0.8. So 0.8 indicates that it's positive and it's strong because it's above 0.5. It's like if it's above 50 cents, you know that it's strong. This one would be a little bit weaker. So I'm going to call this a weak positive. That's because the dots are more spread out. So weak positive could be like 0.4. So since it's below 0.5, I know it's weak. What about no correlation? What do you think the correlation would be? 0. The closer it is to 0, the weaker it is. Then I go over here. This is strong. So I know and it's perfect, so it's going to be 1, right? It's really strong. But what sign is going to be in front of it since it's going down? Negative. So this one will be -1. Perfect, negative. And it's only perfect if it's perfectly in line. This one is pretty close, so what is it going to be right here? Strong negative. And so I know it's like close to, I'm going to put 0.8, but the sign is going to be negative because it's going down. And then this one is like a weak negative. And so I could put -0. Does that make sense? Does anyone have any questions about that? No, yes. Okay. The second thing we're going to be learning about, turn that little half sheet over, is like real world examples of positive and negative correlation. So turn that over, and we're going to talk about real life examples. So here's positive correlation. And you're going to draw this right on the back of your paper. And negative correlation. Positive is as one thing increases, I can just call it as X increases, Y increases. So for example, like the more I study, the higher my grades get, right? That would be an example of positive correlation. So the more I study, the higher my grade will be. Now, we're also going to be learning about causation. Causation, what do you guys think causation means? Like one thing causes the other. So this one, the more I study, does studying cause your grade to be higher? Not really, right? Like studying helps you retain the material. So there's little steps in between. So that wouldn't be causation, just correlation. Who can give me another positive correlation? As one thing goes up, the other thing goes up. Any example? Any real life example? Go for it. Sure. The more you go to practice, the more games you go in. The more you practice, the more game time you get. And so that's correlated, right? Unless your coach keeps track of it and he's like, okay, what if you just go to practice, but you're not that good? Are they going to play you? No, right? So if you go to practice every day, it doesn't cause you to have more playtime. It causes you to get better and get more playtime. So this wouldn't be causation, right? Causation is only if one thing causes the other to happen. Anyone want to give me one more example?
Point of interruption. If you are participating in the Food Expo, please head to the auxiliary gym at this time. You are participating in the Food Expo, please head to the auxiliary gym at this time. Thank you.
Does anyone want to give one more example? Does everyone get what positive correlation means? Like as one thing goes up, the other thing goes up. Like the more, let's do one thing. The more fights I get into, the more ISS I get for hosts. Now, I'm doing this one because I don't want you guys to mistake positive as being good. Positive just means as one thing increases, the other thing increases. So this one right here, would that be causation? Like if you get into fights, you're gonna get OSS, right? That's causing one thing to happen. So not only is that positively correlated, that's gonna be also an example of causation. Does that make sense? Like you know if I'm getting in a fight, you know you're gonna get OSS, right? So one thing causes the other thing to happen. Does that make sense? Yes, no, maybe. How the other two aren't causation. All right, this one is as X increases, Y decreases. So it doesn't mean it's a negative thing happening. It just means as X increases, as one thing increases, Y decreases. Who can give me an example of something that decreases? What did you say? Sure. The more I use my phone, the less battery I have, right? The more I'm on Snapchat, the less battery I'm gonna have in the end. So the more I use my phone, the lower my battery. Would this be an example of causation? Right? You know if you're on your phone, it's going to waste your battery, right? That's why it wastes, because you're on. So when you're on your phone, this would be an example of causation. So not only is it negatively correlated, it's also causation. Who can give me another example? That was a good one. Anything. As one thing goes up, the other thing goes down. I'll give one. The more you're absent, the lower your grade. Would that be causation? Because there's steps in between, right? Because some people are, when they're absent, they make up their stuff right away, or they make sure to do it while they're absent, right? So it's not causing one thing to happen, but more likely they're not. It's going to take them a little while. So that's negatively correlated, but it's not causation. Does that make sense? Does anyone have another one? Anything? What about as the temperature, I'm going to write as the temperature increases, the less layers I wear. So like as it gets hotter out, are you going to be wearing more layers or less layers? Like jackets, coats, things like that. Less, right? Would that be an example of causation or correlation? Causation, right? Because the weather is causing you, like that would be really uncomfortable. It's causing you to not want to wear more layers. But if you just correlation?
It's correlation.
Because there's that step in between.
Yeah.
Is that what it is? Yes. It isn't causation. Cross that out. It's causing you to be worse in that steps in between. It's causing you to be hotter, but it's not causing you to not wear layers. Some of y'all are going to wear sweatshirts no matter what. Cool. Does that make sense? Okay, so you're going to open up your packet, and we're going to practice the first 2 pages this next lesson, so skip over that. And we're going to scatter plots and correlation. So this one right here. So where it says scatter plots and correlation. And so all I want you to do, the first thing I want you to do is identify if it's positive, negative, or no correlation. So right here. Positive, negative, or no correlation. So all these graphs, you're just writing positive, negative, or no. Then I want you to write weak or strong. So over here, like, is this positive or negative? Positive. And would it be strong or weak? It's pretty strong, right? Like if I were to draw a line, they would all be touching. So that'd be a strong positive. So I want you to go through those different graphs and just write, is it positive or negative, weak or strong? Or if there's no correlation, just write no. That means that that's a, like, no sort of pattern. If they're in the middle, a lot of them will kind of be, they're not weak or strong, but they're a correlation. They're in the middle. It would be like a moderate correlation. For the ones that are negative. Okay, cool. Victor, what's this one? Positive, and is it strong or weak? It's pretty strong, right? They're all pretty close together. Kamari, what did you get for this one? Weak what? Positive. What do they all have in common? They're positive correlations. So right here, what they have in common is positive correlation. Cool. Damon, what did you get for this one? No. Ron, what did you get for this one? No. And Angel, what did you get for this one? No. So what do they all have in common? No correlation. Cool. Tyreek, what did you get for this one? Weak. And then is it negative or positive? Perfect. Brixiana, what did you get for this one? It's negative. What did you say before that? Is it weak or strong though? It's pretty weak. And then Keandra, what's the last one? Is it strong or weak? It's pretty strong, right? Like if I were to draw a line, see how they're pretty close to the line? This is more likely to be a strong negative. We're going to learn how to put it in our calculator and actually find it. But altogether, what are these all have in common? They're all one type of correlations. Negative. Does everyone understand about the graphs, like that sort of stuff? Cool. Turn to the next page. The value, we already talked about this, the value of R is always from -1 to +1. So here's like, it's still strong. You can see the negative and positive just mean what type of correlation. The closer it is, without ignoring the sign, the closer it is to 1, the stronger it is. So what you're doing right here, this is helping you kind of get started with just looking at a number. You're telling me if it's positive or negative. That just, so like 0.89, is that positive or negative? That number, positive. So I know it's going to be a positive correlation. And is that weak or strong? Strong, right? Because if it's over 50 cents, I just think, if it's over 0.5, I know it's strong. So now you're going through each one and you're just circling, is it positive or negative? And then is it weak or strong? Give you another minute and I'm just going to
Oh.
All right, let's go over this. Jordan, what's the second one right here? Positive or negative? Negative. And is it weak or strong? Weak. Did everyone get that? Because remember, we don't look at the sign, but 23 cents is a lot lower than 50 cents. Cool. Connie, what about the next one? Was it negative and weak or strong? Strong. Perfect. Kamari, what's the next one? Positive. Yeah, because it's above 0.5. And then, Victor, what's the last one? Positive. Strong. Great. Perfect. Everyone get that part of it? Cool. So now we're going down to here, and this is the part people struggle with the most. What you're doing is it's matching. So you're figuring out, okay, which one of those numbers goes to each graph. So the first thing I would figure out, okay, which graphs are negative and which ones are positive. Then you figure out, okay, which ones are the strongest, which ones are the weakest. So you're matching those correlation coefficients with their graphs. So see if you can try that. I'll give you an example right here. So like this one right here, if I draw a line, first of all, is that positive or negative? Positive. And is that weak or strong? Strong. I would say that's one of the stronger ones here, but it's not perfect. So which one is a strong but not perfect positive correlation? 0.96. So I would write 0.96 right here, and then I would cross it out. So you're going through each one and figuring out which one goes with which graph. Does that make sense? So I would start with which ones are 1 and negative 1 to at least be able to cross those out. Mm-hmm. Mm-hmm. Yep. Yeah. Just like it's ELA 2 days here, or is it 1? It's 2. How many of you are taking 9th grade lit milestone? Just raise your hand. 9th grade lit milestone. How many of you are in 9th grade? That's what you're doing. Or 9th grade. Okay. How many are not taking 9th grade milestone? Jordan, are you taking 9th grade? You know, 9th grade. Okay, cool. All right, let's see if you got this. So, Allison, what's this first one? 1. See, it's perfect. It's cool, and I'm going to cross it out when I'm done. Brixiana, what's this one right here? -1, because it's perfect. Beautiful. So I'm going to cross that out. Kamari, what did you get for this one right here? 0, right? There's not any correlation there. Jasmine, what do you get for this one? Good. -0.90, because if I draw a line, it's pretty close to being perfect. So I'm going to cross that out. What did you get for this one, Keandra? -0.42. Let's see. Yeah, so it's pretty weak, so it's going to be -0.42. What about this one? It falls pretty close to the line. Angel, what do you get for this one? -0.72, perfect. And that means this one is what, Damon? 0.72, perfect. Does that make sense, how we do that? Y'all got that? Yeah. All right, last part is practicing the word problem. So go to the next page where it has the different like word problems, like these. And so what you're doing right here is you're writing positive correlation, negative correlation, or no correlation. So it's positive, it's not strong or weak, you're just writing positive, negative, or no. So remember, positive means as one thing increases, the other thing increases. Negative means as one thing increases, the other thing decreases. And no means like they're not related at all. Like height and what you get on your test, that's not related. Another minute, you're just writing positive, negative, or no. Cool. All right, let's start with this one, Kamari. The amount of time you spend working out and how much you bench press. Positive, right? So the more I work out, just like the one that Tyree told us, the more you work out, the more likely you're to play. Same thing with this one. Keandra, what about this one? The amount of time jogging and how fast you can run a mile. It's negative. Did anyone put negative? Be careful with these. The faster, if you run a mile faster, if Kamari runs it in 5 minutes and Keandra runs it in 6 minutes, who's faster? Kamari or Keandra? Kamari, right? So the less time. So remember, the less time you run a mile is how much you spend jogging, the less time it takes you to run a mile. So that would be a negative correlation. Does that make sense? So just be careful because they may try to trick you. I know the test tries to trick you. What about this one? The height above Earth and the amount of oxygen present. You guys can shout it out. It is correlated. Think of like astronauts, how they have like why do they have that little thing on their head? They have a lot of oxygen or no oxygen up in space? No oxygen, right? So the higher you are, the less oxygen there is. So what would that be? A negative. Does that make sense? The height of a person, how smart they are? No, right? The weight of a car and the miles per gallon it gets. So the more the car weighs, the less miles per gallon it gets. So because it takes more gas to move that car, that's going to be negative. Does that make sense? Okay, last thing before you practice on Delta Math is this right here. You're not doing the bottom part, you're doing the bottom part later. This part, what you're doing is you're just putting them in order. So starting with the strongest negative over here and the strongest positive over here. So you're just putting them in order, like for A, B, C, D, E. So starting over here with the strongest negative, and this should be the strongest positive. All right, so what would this one be right here? E, because that's the strongest negative. What's the next strongest negative? C. And then the next strongest, A. And then we start going up. So what's the weaker positive? D. And then the last one, B. Y'all get that? Beautiful. Okay, so now you're just going to work